All right, everybody. So, this is our video on balancing reactions. This is one of the most fundamental things that we will do in this reactions unit is learn how to balance chemical reactions. So far, I've just given you some things like this where you see. Well, we'll just take this first one: Na sodium plus Cl2 chlorine goes to NaCl, right? Table salt. If you'll notice, I'll get our little title out of the way here. If you'll notice on this, and this is just an aside, we see chlorine is Cl2. That's something we'll talk about later in class, but that is what's called a diatomic molecule. But we'll talk about that more later. There's 7 of them. We'll identify them all. You'll get good with those. All right. So in this video, I'm going to teach you how to balance these reactions. So let's do this. All right, balancing chemical reactions. The premise of it is, and you've probably heard this thrown around before, mass can neither be created nor destroyed. That's called the conservation of mass. The conservation of mass tells us that we have to start with the exact same amount of mass that we end with. So if we have one sodium atom to start, one sodium atom, that means we have to have one sodium atom to end. If we have two chlorine atoms, right, that little 2, then we have to have two chlorine atoms to end. That's how we can tell, looking at this reaction, it is not balanced right now because we have two chlorine atoms to start with, but we only have one chlorine atom to end with. That is an unbalanced reaction. That means we have to balance this reaction. The way we do this is it's kind of like just a little bit like math. What we need to do, and I will walk you through this whole process here. What we need to do is just look through the reaction. The first thing that we'll do, and we're on this number 1 right now, the first thing that we'll do is just label all the elements that there are. Well, the first element we run across is sodium, Na. The second element we run across is this chlorine, Cl. All right, then we get this arrow. All right, the arrow tells us that on the left of the arrow is the reactants. That's what we start with. Left of the arrow is the reactants, what we start with. On the right of the arrow is the products. It's what's produced, or what we end with. We have to have the exact same number of every element in the reactants as we have in the products. So that's what we're going to do over here. We're going to create this little table, and I'll label this R for reactants, P for products. Right now, in the reactants, we have one sodium, right? Because there's no subscript down there. We have one sodium. And then in the reactants, chlorine Cl2, we have two chlorines. Okay, and then we get to the arrow that tells us now we're in our products. So we have one sodium and we have one chlorine. Okay, if we just look at the sodium here, just look at the sodium. Well, we have one sodium on the left and we have one sodium on the right. Those are a little dark. We have one sodium on the left and one sodium on the right. Perfect. Those are balanced because we have to have the same number of sodiums in the reactants as we have in the products. But chlorine, if we look at this, maybe I'll highlight this pink or red, because chlorine, we have 2 in the reactants, but we only have 1 in the products. Well, we need to have 2. We need to have 2 in the products as well. So what we'll do is we'll come to where we see products. We'll come to where we see products, and this little blank that I've left for you in front of this line. This blank I've left for you in front of the products, in front of NaCl, that is for us to put a number, or in math you would call it a coefficient. We will put this, because we can't have just one, we have to have two. So in the products here, we will put a 2 because we need 2 chlorines. What this does is this essentially takes 2 times the entire unit of NaCl. So this means that there's now 2 sodiums, and this means that there's 2 chlorines. Okay, so instead of this 1, we now have 2 sodiums, and instead of that one, we now have 2 chlorines in the products. Okay, so now, good, we have chlorine, we have 2, and we have 2. Perfect. But now the problem is we changed how many sodiums there are. There's 2 sodiums now in the products, but we only have 1 in the reactants. Well, what do you think we're going to do? Instead of 1, we need to have 2, so we multiply it by 2. That's what that number in front does. It multiplies. So we multiply that by 2. Now we have 2 sodiums. Let's keep track of that. Now we have 2 sodiums. All right. Now 2 sodiums on the reactants, 2 sodiums in the products, and we are done. And we are done. So I'll just get these out of the way there so you can see this. That is our final reaction. So this is our balanced reaction right here. 2 Na plus, if we have a blank here, that essentially means 1. That's just like the subscripts. Like we wouldn't write Na subscript 1. We just say there's Na. That just means there's one of them. So if we leave this blank, that just means that there's one of those, 1 Cl2. But I'll leave it blank. It means just 1. So 2 Na plus 1 Cl2. This arrow sign we might say yields or gives or reacts to make 2 NaCls. Okay, there's our first one. Congratulations, you just balanced your first chemical reaction. Let's move on to number 2 now. Let's move on to number 2. So number 2, we have this reaction here. Ag2S, oh, and there's our arrow, yields. We'll do that in a different color. Ag2S yields Ag plus S8. Okay, so there's sulfur 8. Okay, let's do this. So remember, the first thing we do is we're going to write down all the elements that there are. Ag, silver, that's our first one. That's our first element that there is. Sulfur, S, that's the second element that we have. Oh, then we hit the arrow. Okay, so that means we're done. Those are the only 2 elements in this reaction. Okay, so we have silver and we have sulfur. Now we just need to make sure we have the same amount on the reactants as we do on the products. All right, let's tally it up. What do we have so far? Well, silver on the reactant side, Ag, there's 2 of them. And then on the reactant side also, S, just 1 sulfur, only the 1. Okay, now we hit the arrow, so now we're into the products. Ag, silver, well, there's only 1 of it, so 1 silver, plus S8, oh, sulfur 8. Okay, that means there's 8 sulfurs. There are 8 sulfurs. All right. So let's go down the line and see what can we do to make these all balance together. Okay, so Ag2, I'll just typically go the first element that I see. So Ag, silver, there's 2 of them on the products and only 1 of them on the reactants. So we need to make sure that there are 2 of them, or sorry, there's 2 in the reactants and 1 in the products, but we need 2 in the products. So that's how we do it. So instead of 1 in the products, now we have 2. Okay, silver is good. Now we have to balance sulfur. Well, sulfur on the left, there's only 1. And on the right, there are 8. So what do we have to multiply this one by to get up to 8? 1 times 8 gives us 8. Okay, so remember this 8 distributes just like in math. So now there's 8 times that Ag2. So there's 8 times that Ag2. That means that there's, instead of 2 silvers that there used to be, now there are, sorry, I'll keep crossing off. There's not just 2. Now there are 16 silvers, right? 8 times 2. But then for the sulfur, the S, 8 distributes over there, S. Now we essentially have 8 of those instead of just the 1. Okay, so now sulfur is good. We have 8 in the reactants and 8 in the products. 8 and 8. So sulfur, we're done. But silver, now we have 16 on the left and 2 on the right. So instead of having this 2, because right, we have that 2. So instead of that 2, let's just go back to 1. Let's go back to where we started and figure it out. How many silvers are we going to need to get there to be 8? Or sorry, to have 16 of those? Well, we multiply 1 by 16. So if we put a 16 in front of it, now we have 16 silvers on both sides, and we have 8 sulfurs on both sides. Perfect. All right, so we're done. We have 16 silvers. All right, 16 silvers on both sides, 8 sulfurs on both sides. That's what we needed. So that now is our balanced chemical reaction. 8 Ag2S yields or produces 16 silvers plus, remember this blank, it's just 1 S8. All right. At this point, if you need to pause and go back to rewatch them explained in more detail and slower, please do so. Otherwise, I'm going to speed up just a little bit in how I do these. Go a little bit faster for these next few, so we can make sure that we get through it all and you don't have to watch a really long video. Okay, number 3. Number 3, we've got aluminum plus and then FeN, so iron nitride, gives us or yields. I always like to highlight this arrow sign because that really tells us from reactants, really tells us now we're in the products. So yields, okay, then aluminum nitride plus iron. Okay, so remember the first thing is I'm just going to list all the elements that are in this reaction. First one we come across is aluminum. Next one we come across is iron, Fe. Last one we come across is this nitrogen, N2. Then we hit the arrow sign. That means we are done listing elements. So on the reactants and on the products. All right, let's list how many of these we have. So aluminum, there's 1 on the reactants. Iron in the reactants, there are 3. Nitrogen in the reactants, there are 2. Okay, now we hit the arrow, we're in the products. Aluminum, there's 1. Nitrogen, there's 1. So come to nitrogen, there's 1. And then iron, there's also 1. Okay. Well, so far it looks like aluminum's good. Remember, just like before, when we put this 8 in front of here to fix the sulfurs, that also changed the silver. That might happen. We'll see. All right, so aluminum's good. We'll just move on to the next one. So iron. Well, in the reactants, there's 3 irons, but in the products, there's only 1 iron. What could we multiply 1 by to get to the 3 that we have? Hopefully you know that. That's 3. So 3 irons there. So now instead, in the products, this 3 distributes, but oh, there's only iron there. That makes it easy. So the only thing that changed is iron. Okay, so aluminums are balanced. Iron is balanced. Now we just have nitrogen. Well, nitrogen, there's 2 on the left and there's 1 on the right. So what do we multiply 1 by to get to 2? That's right, 2. Okay, so now instead of that, we got 2 there. But remember that 2 applies to the aluminums and the nitrogens. So what else did we just change on the right? We just changed the aluminums. Now there's 2 aluminums. Okay, so there's 2 aluminums in the product now. Now we need to change that in the reactants. So aluminum here, instead of 1, we need 2. So we can multiply that by 2. Okay, now 2 aluminums in the products and in the reactants. 3 irons in the products and in the reactants. 2 nitrogens in the products and in the reactants. And if you look through our reaction, you see the same thing. 2 aluminums, 3 irons, 2 nitrogens. Then over in the products, remember this 2 distributes. 2 aluminums, 2 nitrogens, and then 3 irons. So that becomes our reaction right there. All right, and then remember, any blank, what does that imply? Well, that blank applies a 1, but we won't write it because, right, scientists are lazy. If there's ever anything that's just a 1, we just leave it blank. Okay, up next, we've got this number 4, NaClO3. This is sodium chlorate. If you don't have to know the name of that, but sodium chlorate, that yields, this sodium chlorate yields sodium chloride plus oxygen. This is another one of those, I just mentioned it right at the beginning of the video. This is another one of those diatomic elements. Diatomic, what that means, di, all right, that means from our prefixes we learned earlier, that means 2. Atomic means atoms. There's 2 atoms. So a diatomic element is one that's O2, as opposed to, you can see in the example before, Fe. That's just, there's just 1 Fe. But down here, there's 2 oxygens. We call that diatomic, for there being 2 of them. Okay, but you don't have to know that yet. I'll just remind you that little by little throughout the unit. Okay, so let's see this then. We've got Na, just listing the elements we have. Na, we've got Cl, and we've got oxygen. Okay, then we hit the arrow. That means we're done. So now we need to see, all right, reactants and in products. So in the reactants and in the products. Well, reactants for sodium, for Na, there is, I see just 1. In the products for sodium, I see just 1. In the reactants for chlorine, well, I see 1. In the products for chlorine, I see 1. Okay, oxygens in the reactants, there's 3. In the products, I see 2. Okay, so sodiums are good, chlorines are good, but the oxygens, we have 3 versus 2. We have 3 versus 2. All right. Well, how many times can we multiply 2 to get into 3? The answer is, oh, we can't. We can't. We have to make it a whole number. So this is just like, do you remember when we were, I'll take it over here for a moment. If we had to write a chemical compound between magnesium 2+ and, let's say nitrogen, which has a charge of 3-. If we have to write that formula, what do we do? Well, we could either do this and, right, we get another Mg2+. Now we have 4. So nitrogen 3-. Now we have 6 over there. So we need 1 more Mg2+. We have 6. We could either do that. So we get 3 magnesiums and 2 nitrogens. Or, all right, the other thing you can do, take the number and bring it down, take the number, bring it down. So if we were to write this formula, it'd be magnesium 3, nitrogen 2. So the one that had a mass of 2 gets a 3. The one that had a charge of 2 gets a 3. The one that had a charge of 3 gets 2. We can do that over here just the same. So the oxygen, the one that there's 3 of them, we'll just take that and swap that over. And then the one where there's 2 of them, we take that and swap it over. And those become the coefficients, or what's in front. So this one Right, 3 oxygens needs 2, but then 2 oxygens needs 3. Sometimes you'll hear me call that 3 and 2 switcheroo. What this does is this gives us 2, right? The 2 distributes to everything here. So instead of 1 sodium that we had before, now we have 2 sodiums. Instead of the 1 chlorine, now we have 2 chlorines. Instead of the 3 oxygens, now we have 2 times 3 oxygens. This gives us 6. It's important to note that this is times. We are multiplying. It is not adding. It is multiplying. Okay, so we got the 2 over there. We took care of all those. But now we have this 3 over on the right side. We have 3 O2s. So instead of 2 of them, now we do 3 times that little 2. Now there's 6 oxygens. Because the way that works, and here's why we multiply. I'll delete all this stuff over here. But why we multiply is, let's say we have this oxygen bonded to another oxygen. And if you were to draw the Lewis structure, you'd get that. If I say this, if I say 3 O2s, that means that I have 3 of the oxygen molecules. So I have 3 molecules of O2. So here's one. Here's our second molecule of oxygen. But we have not 2 of them, we have 3 of them. So we need a third molecule of oxygen. You could take the time to draw the Lewis structure, but that's what it looks like. So then, why do we have 6? Well, count up the oxygens. 1, 2, 3, 4, 5, 6. There are 6 oxygens. That's why we get this number over here. That's 6. That's why it's multiplied instead of adding. So it's 3 times 2. Okay, so now our oxygens are good. 6 oxygens, 6 oxygens. But what about this chlorine now, or the sodium and the chlorine, actually? Let's look at the sodium first. I'd usually just start on the top of the list. It doesn't really matter which order you do it, just as long as you take care of all the elements. I usually just start at the top of the list. It helps me keep track of things. So 2 in the reactants, but only 1 in the products. So what do we have to multiply the products by? 2. So we put a 2 in front of that. Right, just as in all these coefficients distribute. So instead of 1 sodium, now we have 2 sodiums. And instead of 1 chlorine that we used to have, now we have 2 chlorines. Okay, well, that just took care of all of it for us. So we have 2 sodiums, right? 2 sodiums, 2 sodiums. We have 2 chlorines, we have 2 chlorines. We have 2 times 3 oxygens, so 6 oxygens. And here we have 3 times 2 oxygens, so 6 oxygens. Perfect, we are done. I'll erase these arrows just so you can see them a little bit better. Oh, I should do these in orange instead of in the blue. There we go. So that becomes our final reaction. 2 times this NaClO3 yields 2 NaCl plus 3 O2. Okay. The new thing on this example, actually, I'm going to do number 6 before I do number 5. Do number 6 before I do number 5. Okay, number 6. Well, we've got, all right, first thing we do, list out all the elements that we have. There's a lot of them here. All right. So we've got zinc. We've got sulfur. Next one we come across is aluminum, Al. Last one, phosphorus. And that's before we get to that arrow in the middle, the yield sign, which tells us that's all the new elements that we have. So reactant side, product side, let's see. Okay, well, in the reactants, there's 1 zinc and 3 zincs in the products. Okay, so I'll kind of show you the shortcut that will basically eliminate the need for us to have this. You can always feel free to have this. Always, always, always feel free to do that. But that's more of the learning mechanism as opposed to the practicing mechanism. So I'll try without it on this. Hopefully you can follow. If you have questions though, please, please, please let me know. Happy to work through this with this mechanism over here to help you learn a little bit better. Okay, but when I don't use this over here, when we don't use these, what that does is now I'm just going to take this one element at a time. So I'm just going to find zinc on the reactants and zinc on the products. Well, how many zincs are on the left? Just one. How many zincs are on the right? There's 3. Okay, so we need to have the same number on the left and right. There's 1 here, 3 here. So that means we will need to multiply this side by 3. Now we have 3 zincs and 3 zincs. Okay. Oh, but what did we just change? Anytime we put a coefficient, we always have to ask what we just changed. So zinc, we just put a 3 there, but that also changes how many sulfurs we have, right? Because that 3 multiplies to the sulfur as well. Okay, well, we haven't looked at the sulfurs yet. So sulfur, and here's the sulfur over here. Well, now we have 3 sulfurs. And on the product side, oh, we have 3 sulfurs. Perfect. We're done with sulfur. Okay, moving on to the next one, aluminum, Al. Well, there's 1 aluminum on the left, but over here, oh, there's 2 aluminums on the right. Well, we can't have 1 aluminum and 2 aluminums, right? There's aluminum and aluminum. We can't have 1 and 2. We have to have the same number. Multiply the 1 by 2 to make it 2. So now we have 2 aluminums on the left, and we have 2 aluminums on the right. But oh wait, what did we just change? We just changed that phosphorus as well. Oh, but we haven't looked at phosphorus yet, so that makes it all right. So there's on the left, there's 2 phosphoruses. On the right, oh, there's 2 phosphorus. That makes it nice and easy. We don't have to do anything if there's 2 and 2. Okay, last thing to do is just double check. So 3 zincs, 3 zincs. Perfect. 3 sulfurs, 3 sulfurs. 2 aluminums, 2 aluminums. 2 phosphorus, 2 phosphorus. Perfect, and we are done. So that is our reaction right there. So we have 3 zinc sulfides plus 2 aluminum phosphides yields, remember this is 1 zinc phosphide plus 1 aluminum sulfide. All right, I'm going to go back up to number 5 now. Halfway done with the examples, but I'm going to take the rest of these a little bit faster. All right. These here, I just want to erase that all for a moment. Let's erase that. Perfect. So we can just have some extra room to write. This one, number 5 right here. But what's different about number 5 is we are now introducing a reaction with polyatomic ions. These are our polyatomic ions. You might recognize these from our list, but we have NO3, right, nitrate, and we have CO3, carbonate. What we do when we get a reaction that has a polyatomic ion is if you see the polyatomic ion on the left and on the right, then we don't have to separate it out into its own elements. We can just put it as one element. So in this, we have NO3 is one element. Essentially, we can take the potassium that is bonded to as well. Keep going along. Hydrogen. Okay, hydrogen, that's another element. And then CO3 carbonate. Carbonate, that's our last one. So essentially now, instead of balancing nitrogens and oxygens and carbons and oxygens, what we're going to do is we just balance the nitrates and the carbonates. Makes life a lot easier. All right, so let's do this just like we did the one below. We've got potassium on the left, potassium on the right. Right, our arrow's right in the middle. Potassium, well, there's one potassium on the left, there's two potassiums on the right. So we need to have two potassiums total, 2 times 1. Okay, we did the potassiums. Now we can move on to this, right? This NO3. There's now 2 NO3s. We just changed that. So then over on the right side where we only have 1 NO3, what are we going to have to put in front of it? Well, we need a 2. Okay, so we just did 2 NO3s, but now we need to worry about, we just changed the number of hydrogens here. There's 2 hydrogens, but on the left, oh look, there's 2 hydrogens. Wonderful. Okay, so we've done potassium, we've done nitrate, we've done hydrogen. Last one is just carbonate. Carbonate, 1 on the left, 1 on the right. Perfect. All right, it looks like we're done, but let's go and double check ourselves here. All right, we have 2 potassiums, 2 nitrates, 2 potassiums, and 2 nitrates. Over here we have 2 hydrogens. We have 2 hydrogens. We have 1 carbonate, 1 carbonate. Awesome. So we have the same number on the left as we have on the right for every single one of those. That means we are done. This is our balanced reaction. 2 potassium nitrates plus 1, this is called carbonic acid. You could call it hydrogen carbonate. Yields 1 potassium carbonate plus 2 hydrogen nitrate. That's also called nitric acid. All right, we only have 4 more left. Only 4 more left. This next one here is a combination of the 2 things that we just did. Right? I see this. First thing I'm going to notice, I see an OH. Well, that appears on the left and on the right. Well, we know OH is this, right, hydroxide. We know hydroxide is a polyatomic ion, so let's just treat it like a polyatomic ion. So we have the 4 groups or elements that we'll consider: lead, hydroxide, copper, and oxygen are what I see. That's all before our yield sign. Okay, on the left we have 1 lead, on the right 1 lead. Great. On the left we have 4 hydroxides, on the right only 1 hydroxide. So what do we do? Times 4. Okay, but then that times 4 for the hydroxide also means times 4 for copper. But on the left, we have 2 coppers. So instead of 2, we need 4. What do you multiply 2 by to get to 4? Times 2. So that's 2 of the Cu2. That means 4 coppers. Oh, but that also changed the oxygens. There's now 2 oxygens over here, but look at that, 2 oxygens. Okay, I think we accounted for all the elements, but let's go back and double check, shall we? So we've got this 1 lead on the right, 1 lead. 4 hydroxides, 4 hydroxides. All right, that 4 hydroxides. 2 coppers, or I'm sorry, 2 times Cu2, so that's 4 coppers and 4 coppers. Then 2 oxygens, 2 oxygens. Perfect. We're done. All right, number 8. Number 8. Okay, let's just do this process here. On the left, we've got 3 carbons. On the right, 1 carbon, so we need times 3. On the left, 8 hydrogens. On the right, only 2. So how do we get from 2 to 8? Oh, what do we multiply by? Times 4. Okay, carbons and hydrogens were good. Now we just need oxygens. Oh, here's something that we haven't encountered yet. There are 2 places where oxygen exists on the right side of this reaction. So we have to take those, And those both exist, so we add them together. So we have 3 times O2, that gives us 6 oxygens. And we have 4 times O, that gives us 4 oxygens. So how many oxygens do we have total? We have 10 oxygens. Okay, so on the right we have 10 oxygens, but on the left we only have 2. How do we get from 2 to 10? Times 5. All right, so this means 1 C3H8 plus 5 O2 yields 3 CO2s plus 4 H2O. If you have any questions, let me know, but make sure you tell your friends to watch this video before class. You can always come back and revisit this if you need to review how to balance equations. That being said, have a great rest of your day. I will see you in class.